Now be solving simultaneous linear equations when the equations has fractions. Now we've been told to solve for x and y if x over 2 plus y over 4 is equal to 1 over 2 and x over 3 minus y over 5 is equal to 1 over 9. Now looking at this equation, it looks overwhelming at first glance, but we can see after this that it's just the same way of solving it. So we are going to do something simple that we already know how to do, which is the first thing is we are going to rewrite the equations in solution. Rewriting the equations, we have it as x over 2 plus y over 4 is equal to 1 over 2, and we're going to name it equation 1. And we have the other one that says x over 3 minus y over 5 is equal to 1 over 9. We are going to name this equation 2. Now, the next thing for us to do is that we are going to find the LCM of the denominators of this equation 1. So, when looking at it, the LCM is 4. The whole denominator, the LCM is 4. So, what are we going to do with that? We are going to multiply all through by 4. That is, we are going to multiply equation 1 by 4. So, when we do that, that is 4 times x over 2 is just like saying 2 divided that 4, giving us 2. So we're going to have 2x. 4 times this, we are going to have y, because 4 will divide 4, is equal to 4 times half, that's going to give us 2. So this is the equation we're going to be working with. We can see that the equation now looks as normal as we know equations to look like. Okay, so for the second one, we're going to look for the denominator. And looking at this, 3 and 9, that's 9 is the LCM of 3 and 9. So we are just looking at 5 and 9. So their LCM is 45. Or you can work it out in a rough sheet. So the LCM of these denominators is 45. So we're going to multiply every single term in this second equation by 45. To eliminate the fraction. So when we say 45 times x over 3 is just like saying 3 divide 45 and then the coefficient. 3 divided into 45, we have 15. So we have 15x, and then 45 times this, that's 45 divided by 5. We're going to have minus 9y is equal to 45 times 1 over 9 is equal to 5. So we can see very simple equations now, and then we can now solve the normal way we know how to solve. Now, the normal way we know how to solve is to look at the coefficients of the variables and see if any of them is equal. If none of them is equal, we are going to equate any one of them. What do we mean by that? When we look at the coefficients of x, it's not equal to and 15. So, to equate them, we can say 15 times this equation. So that's 15 times 2 is 30. And then 2 times this equation, giving us 30. Or we look at the coefficients of y, and then we say 9 times this equation, so as we have 9y, and then there is also 9y here. And then it's advisable to always work with the smallest of values. So what we are going to do is we are going to multiply equation 1. Okay, now this time around this becomes equation 3 and this becomes equation 4. Whenever we alter an equation, it's advisable to rename them. So what we are going to do is we are going to multiply equation 3 by 9. So equation 3 times 9, we multiply every term in it. So 9 times 2x is 18x. 9 times y is 9y. 9 times 2 is equal to 18. Fine. So we just repeat this equation 4. So equation 4 still remains equation 4. We have 15x minus 9y. That's 15 equation 4 is equal to 5. Now, the next thing for us to do is we look at this. We can see they have different signs, opposite signs. So all we have to do for them is to add it. So plus 9 plus minus 9y is just like saying plus minus is minus. So plus 9 minus y, that is 9 minus y, that's 0. So we eliminate it by adding. So we say adding. We just say add. When we add the two equations, we have 18 plus 15. 8 plus 5 is 13. We carry on. So 33x. This is already 0. We've eliminated. And then we have 18 plus 5 is 23. Okay, at this stage, we already know what to do. We divide both sides by 33. Okay, and then when we do that, we find that x is equal to 23 over 33. I know this is a weird, like this is a fraction, but some result into fractions. Now we are going to solve for y. Now coming to this side, decide to solve for y. So how do we do that? We are going to substitute this into any of our equations, and it's easier to work with simple equations like these ones we've simplified by eliminating that fractions. So let me substitute into equation 3. So we have that 2 instead of x, we're going to have 23 over 33, and plus y is equal to 2. Okay, we have it as 44 over 33 plus y is equal to 2. Same way we eliminated fractions by multiplying by the denominator. So we can also do that here. We multiply all through by the denominator 33. So we have 44 plus 33y is equal to 66. We collect like terms. We have that 33y is equal to 66. 44 crosses over to become minus 44, giving us 22. So we have that 33y is equal to 22. So we are going to say divide both sides by 33. So we have that y is equal to 22 over 33. So reducing this to lowest terms, we have that that's 11 can divide into these two values. So when we do that, we are going to have 2 over 3. That y is equal to 2 over 3. And x is equal to 22 over 33. Oh, looking at this just now, I just found out that I copied out the wrong thing. This is 23 and here I have it as 22. Please, this is 23. So if this is 23, that means 2 times this is 46. So this is 46. And 66 minus 46 is going to give us 20. So we have 20 over 33. So this remains an equation, a fraction that we can reduce to lowest terms. So y remains 20 over 33. So I take that back. So the solution to this equation is that x is equal to 23 over 33 and y is equal to 20 over 33. So you can do your check later to see that these two satisfies the simultaneous equation. Now let's look at another example. In this example, we have these two equations. Now we're going to rewrite them and then name them equation 1 and 2. But when we write equation 2, it's important for us to change this mixed fraction into improper fraction because it's always easier to work with improper fractions. Now to repeat the equations, we have x minus y over 2 is equal to 1. So this is equation 1. And then for the second one, we have x over 2 plus y over 3 is equal to. Now, the improper fraction will become 2 times 6, that is 12. 12 plus 5 is 17, so 17 over 6. So this is equation 2. Now, looking at these two equations, what we have to do is we are going to eliminate fractions in each of them. So let me do that here. So to eliminate fraction, for equation 1, we multiply every term in equation 1 by 2. When we do that, we're going to have 2x minus y is equal to 2. So this becomes equation 3. So we've eliminated fraction. It now looks like a simple equation. Then for this, the LCM of the denominators is 6. So we're going to multiply every term in this second equation by 6. So doing that, we have that 6 times x over 2 is just like saying 6 over 2, which is 3. So we have 3x. 6 times y over 3, it will give us 2y is equal to 6 times 17 over 6. So the 6 we cancel out, we have 17 remaining. So this becomes equation 4. Now we have our equations in simple terms. Now looking at this, remember that we can either say that we equate the coefficients of x or we equate the coefficients of y so as to eliminate them. Now I'm going to equate the coefficients of y because that's simple. It's simpler that way. We just multiply equation 3 by 2. So we have 2y, 2y. Or we can just say multiply this by 3. So we have 6x. Multiply this by 2. We have 6x. But let me go by the smaller value. So we say equation 3 multiplied by 2. Equation 3 multiplied by 2, you have 4x minus 2y is equal to 4. And then we repeat equation 4. Equation 4 remains 3x plus 2y is equal to 17. Now looking at the ones we want to eliminate, we can see that when we add them up, that is minus 2 plus plus 2. So that's plus plus giving us plus. Minus 2 plus 2 is 0. So we eliminate by adding. Now, if you've noticed, if the ones we want to eliminate carries opposite signs, we usually add. If they carry same sign, minus minus or plus plus, we usually subtract to eliminate them. So we are going to add 4x plus 3x is giving us 7x. This is already 0 equal to 4 plus 17 is 21. And then we see that we divide both sides by 7. We have that x is equal to 3. Now let's solve for y on this other side. In solving for y, we can decide to substitute into equation 3. We substitute the value of x into equation 3. When we do that, we are going to have 2. Instead of having x, we have 3 minus y is equal to 2. That is equation 3. And then we have 6 minus y is equal to 2. We collect like terms. Negative y remains here. 2 is already here. 6 comes over to be minus 6. And we have that minus y is equal to 2 minus 6 is 4. And when we do that, that's minus 4. 2 minus 6 is minus 4. We divide both sides by negative 1. We have that y is equal to 4. Y is equal to 4 and x is equal to 3. So these solutions, x is equal to 3 and y is equal to 4, both satisfies the given equations. You can do your check to confirm. Now, we can see these fractions. This is a special case of fractions in which the unknowns are now the denominators. So, for this special case, what we are going to do is we are going to rewrite the equations. And now, we can't say let's multiply all through by the LCM of the denominators. When we do that, it's going to result in quadratic equations, in which that's not what we want to do for these linear equations. So how do we rewrite this? so as to do away with fractions, at least for now. What we are going to do is we are going to say this is 2. 2 is the coefficient, and we are going to have 1 over x. So do you notice that this is same thing as this? Because 2 times 1 over x is just saying 2 over x. Because this is going to just multiply the numerator. So this is a way of writing this. So that this becomes our unknown. It's easier to work that way. Okay, so let's do that for the rest of what we have here. We have 3. We now have 1 over y is equal to 4. So we name this equation 1. For equation 2, we are going to have 4. 1 over x plus 1 into 1 over y. Let me still write 1 over y, or we just have it as 1 over y is equal to 1. So this is equation 2. Now, so this, we've placed them in brackets. We are going to look at them as just the unknown. Just the unknown. Don't read meaning into them till we are ready to open the bracket up. So now, we can multiply this equation 1 by 2 so as to equate the coefficients of x, or we can multiply equation 2 by 3 so as to equate the coefficients of y. So any of them is our choice. Let me just go with the smaller value, which is multiplying this by 2. So when I multiply equation 1 times 2, I'm going to get 4 into 1 over x, and then 2 times this is going to give us 6. 1 over y is equal to 2 times 4 is 8. So I'm going to call this equation 3, and then I'm going to say equation 2. Let me check whether it's plus. Okay, we are going to subtract equation 2 minus equation 3. That is this equation 2 minus equation 3, because these coefficients have same sign, plus plus, so we are going to minus them. So that 4 minus 4 is 0, so we've eliminated that. And then now we have 1 minus 6. Minus coming together is plus, so 1 plus 6 is going to give us 7, and we have 1 over y is equal to, remember it is still subtracting, we are doing 1 minus 8 is going to give us negative 7. So we have that 7 into 1 over y is equal to this. So we are going to divide both sides by 7. When we do that, we're going to find that 1 over y, we have that 1 over y is equal to negative 1, because minus 7 over 7 is equal to negative 1. That's what we got. Okay, now for us to now find what is y, we are going to say that, let me solve that here. We have that 1 over y is equal to minus 1. I'm just going to say over 1, because every whole number is over 1. We're going to cross multiply. We have that negative y is equal to 1 times 1, that's 1. So we have that y is equal to negative 1. That's dividing both sides by minus 1. We're going to get that y is equal to negative 1. So we substitute into any of these equations to solve for x. So let me pick out equation 1, for example. Since we used equation 2 and 3 here, let me pick out equation 1. So in equation 1, we have that 2 into 1 over x minus 3. Remember from here that 1 over y is equal to negative 1. So it's easier for us to substitute it here. 1 over 1, y is negative y. So we have into negative 1 equal to 4. We have that 2, 1 over x minus 3 minus times minus 1 is equal to plus 3 is equal to 4. Then we collect slightest. We have that 2, 1 over x is equal to 4 is already here. Plus 3 comes over to become minus 3. So 4 minus 3 is equal to 1. And then we have that 2 into 1 over x is equal to 1. Now we're going to divide both sides by 2. And when we do that, we are going to have that 1 over x is equal to half. 1 over x is equal to 1 over 2. When we cross multiply, we are going to see that x is equal to 2. That is x times 1 is x is equal to 1 times 2 is 2. So x is 2 and y is negative 1. So the solutions to the equations is y, no, write x first, x is equal to 2 and y is equal to negative 1. So when you do your check, you're going to find that these two solutions satisfies the given equations.